So we've now described not only how we are able to talk about coordinates for space, but also coordinates for time. And the essential idea that we have described is we now imagine that at every location in space, we put a clock. And we use that clock as a means of determining when an event takes place. So we use the red grid, if we're in 3 dimensions, to describe where an event takes place using familiar Cartesian coordinates, say x, y, and z. And we use the readout on the clock at any given location to describe when it is that an event took place. Now, these are examples where we have 3 dimensions of space. Oftentimes, we will simplify and look at just 1 dimension of space. And we described how it is that you synchronize clocks in, say, a 1-dimensional system as this. We have a flash of light that goes off, and each clock has an observer, looks at the flash when it reaches them. They start their clock in motion, but they take into account how long it took the light to reach them. They set their clock forward by that amount so that when it starts ticking, it will be in sync with the clock at the origin. So that's the 1D version. The 2D version is much the same. Flash at the origin, we described, goes off. The observers wait to see that flash, and as the flash passes by them, they start their clock. They know how long it took for the flash to reach them, and in that way, they're able to ensure that their clock is in sync with the clock at the origin, the clock from which the flash originated. And if all of the clocks are in sync with the clock at the origin, they are in sync with each other. This is how we build a space-time coordinate system.